Good afternoon. Today we will discuss a very important experiment, that is Michelson Morley experiment. Michelson Morley experiment. This experiment is performed by two scientists, Michelson and Morley. So this experiment is performed to demonstrate the existence of ether. It is performed to demonstrate the existence of ether and its effect on the motion of absolute frame of reference. So this is the conclusion which we will draw from this experiment, that is the existence of ether. First of all, we have to know that what is ether. Ether is nothing, it is the medium present around the earth. As you know, it is earth and there is an envelope which is surrounded by the earth is called ether. So this is ether, basically the medium of gases surrounded the earth. So we will first prove that is ether exist or not. Obvious answer is yes, ether is existing here. And second, what is effect of this ether? Is this ether affect the motion of frame or not? So these are the two questions for which we have to find the answer from this experiment. So what is this experiment? It is a simple experiment which is performed by Michelson Morley. That is, there is experimental setup. There is a source of light from here and putting a lens on in front of it to get a sharp beam of light. And this beam of light will strike on a plain glass plate which is semi-silvered, means half plate is silvered or it is polished with some opaque material and half is transparent. And it is placed at 45-degree angle. The angle found with axis is 45 degree. So why it is placed at 45 degree? Because when it is placed at 45 degree angle, then we will get two perpendicular rays of light. One is striking with the surface by polished surface, it will bend toward this side, and second which will pass through this medium and it will pass through this side, because this glass plate is semi-silvered, half silvered. So two types of phenomenon of light, that is reflection as well as refraction. It is due to reflection of light. The light will strike on this part and it will reflect to this side, and this is due to refraction of light, because it passed through the transparent medium. So why it is shown a little bit slanting? Because in refraction there is deviation in the path of the light. So these two rays we will obtain which are at right angle to each other. When it is placed at 45 degree angle, it will happen only that case. Now, and at the same distance from here to this side, we will place a mirror M1. Let the distance is d, small d. and at the same physical distance small d, we again put a mirror M2 at right angle to each other. Why right angle? Because the light strike on this mirror, it will retrace its own path in backward direction. Similarly, here. So after striking these two rays with the mirrors, they will again meet at the same point. These two rays are spreading from this point, as well as they will meet again after reflection from the mirrors M1, M2. They will again meet at the same point, and both rays will move toward this side, downward side, and we will observe here with the help of telescope what is the pattern formed in this telescope. Our two rays are reaching a telescope at the same time, or there is a time lag between these two rays. This is our main point, which we will discuss in this experiment. Now, you know that in case of reflection, there is a phase difference of 90 degree, or there is a path difference of lambda by 2 automatically introduced in case of reflection of light. But this path is not introduced in case of refraction. You have studied this type of result in lower classes. That is, in case of reflection, there is an additional path. Oh, sorry, 90 degree, it is 180 degree. Sorry. But there is no any additional path. So to compensate this additional path, which is automatically introduced in case of reflection, we will place a compensating plate, again CP, that is compensating glass plate. So I have introduced this plate in the path of refracted light, refracted, not in the path of reflected, because in case of reflection there is additional path difference of 180 degree or lambda by 2 path difference. But we will introduce an additional compensating plate in case of refraction to compensate this additional path difference by this plate. So this plate is of the standard size, which introduce the path difference of lambda by 2 or the phase difference of 180 degree. Now, the physical distance as well as optical distance both are same in both cases. In case of reflection, the physical difference is d, and it is also d. Physically, both distances are same, but optically there is an additional path difference. So we have already introduced this additional path difference to compensate this difference. So now, in our experiment, both physical distance as well as optical distance in case of two rays both are same. Now, we will find that the time taken by the ray of light for complete journey on reflection and time taken by the ray of light to complete journey in case of refraction. So first of all, we will consider the time taken on reflection. So the time taken to complete journey by reflected light, this one, the first case, reflected light. Let this time taken is t1. This time is t1. First of all, we will split this time in two parts. Time taken to move from this plate to the mirror and again back from mirror to the plate. So it will split in two parts. That is distance d, this is distance d, over velocity plus again on the reverse direction distance d over velocity. Is it clear? What is the velocity in upward direction of light and what is the velocity of light during downward direction? This is the time taken. Time, you know that time is the ratio of distance to the velocity. So, there are two time intervals, that is time of ascent, time of descent, ascent and descent, a sum of two times for complete journey. Now, what is the velocity during ascent and what is the velocity during descent of the light? So, in Michelson Morley experiment, it is assumed that there is an ether. It is already assumed that there is an ether and it is moving along one side. So, this is the velocity v of ether. So, this is a new thing that Michelson Morley has assumed that there is an ether, and when earth rotate, ether will also rotate along with this earth, and the velocity, relative velocity of ether with respect to earth is v. So, this is relative velocity v, velocity of ether. So, when light will move from this point to this point and velocity of ether is also there, it means the light will travel this path actually. If velocity of ether affect the motion of the light, then light will move toward this side. You know that actually light is going in a particular upward direction, but due to the speed of ether, it will trace this path, and in backward direction, it will move toward this side because this velocity is affecting the motion. It is assumed by the Michelson Morley experiment, but practically it is not happened. But in this experiment, it is assumed that the velocity of ether affecting the motion of light. So, the light is upward direction, it is in downward direction. And what is the velocity or distance? So, we have to find the distance, this one distance d, and it is velocity of actually ether, velocity of light. This is velocity of ether along this side, and what is the velocity of this? It is v square minus c square, c square minus v square, c square minus v square under root. So, we can use Pythagoras theorem for this triangle. Along this side it is c, along this side it is v, and this side is c square minus v square under root. So, this is the equation for velocity obtained from the Pythagoras theorem or right-hand triangle method. And when this light will go in downward direction, again velocity of ether is there, v, and this is c, actually the velocity of light, and actual distance traveled by the light is d. So, this is again, it is c, it is v, and it is again c square minus v square under root. So, velocity for ascent and velocity for descent both are same. So, it will become d over velocity c square minus v square under root plus second for descent d upon c square minus v square under root. This is time t1. Is it clear? Equation number 1. So, this is total time. Both terms are same. You may write it as 2d over c square minus v square under root, that is t1. Okay. Or on simplification, we may write it as t1 is equal to 2d, this one, and taking c square common from first term, it will become c. When it comes out from the square root, it will become 1 minus v square upon c square. So, I have taken c square as common from this term, and it is written as 2d by c into 1 minus v square upon c square raised to power minus 1 by 2, because it is square root, that is power 1 by 2, and we will write this as 1 minus v square upon c square raised to power minus 1 by 2, and we will apply Pythagoras theorem at here. 2d by c into 1 minus x raised to power n, 1, and minus minus plus v square upon 2c square, 1 plus nx, and higher power can be neglected because first term is 1 and second term is very, very less than 1. So, we will take only 2 terms, first one and this one is into this, that is v square by 2c square. So, this is basically the time taken. So, we will consider equation number 1, this is actually equation number 1, the time taken for reflection of light. Second, for refracted light, for refracted, this one, refracted. Again we will find the time taken. Let the time taken for whole journey is the sum of time for forward direction d over velocity plus for backward direction d over velocity. Now we will find the velocities for forward direction. You know that light is going on this side, forward direction, this side with velocity c, and ether is also moving or flowing toward this side with velocity v. So the net velocity is c plus v. So d over c plus v, net velocity. And when light is moving in backward direction and ether is moving on right hand side, the relative velocity is d upon c. Oh, sorry, it is c minus v because we will count its relative velocity, c and minus v and c plus v. Okay, this one. Now we will take its LCM. This LCM is c square minus v square. Okay, it is multiply c d into c plus v and plus d into c minus v. It is dc plus dv plus dc minus dv over c square minus v square. Now this dv can be dv. It is 2 dc over c square minus v square. Again we will apply the Pythagoras theorem, binomial theorem. We will make the coefficient first 1. So c square is common and 1 minus v square upon c square. So I have taken the c square as common, and rest thing is 2 dc over c square into 1 minus v square upon c square raised to power minus 1. Because it is only single power, it will become minus 1. And then this T2 will be 2d, this c is cancelled with this c, 2d by c into 1 minus nx, 1 plus v square upon c square. Minus 1 is multiplied with this, you will get v1 plus v square by c square. So this is second time for the second journey, T2. So in first case it is 2d by c 1 plus v square upon 2c square. In second case it is 2d by c 1 plus v square by c square. So there is difference in the time taken for reflection as well as refraction. If there is difference, then we will find the delta t. What is delta t? It is the difference between two time, that is T2 minus T1. T2 means 2d by c into 1 plus v square c square and minus 2d by c into 1 plus v square by 2c square.